Hydrocarbons and other organic molecules are named using the IUPAC system of nomenclature. IUPAC stands for International Union of Pure and Applied Chemistry. The IUPAC rules for naming simple organic molecules is straightforward. First, identify the parent chain. This is the longest continuous carbon chain. Second, identify and name the substituents. A substituent is a group that is not contained within the parent chain. Third, number the parent chain and assign a location to each substituent. It's important to remember that every substituent has its own number or location. 4. Arrange the substituents alphabetically. For the parent name, there's two parts, the root and the suffix. The root names are based on the number of carbons. If we look at a one carbon group, the root name would be meth. Since most of what we'll be looking at is going to be alkanes, we're going to go ahead and add the suffix, ane. The suffix gives us the functional group. So a one carbon alkane would be meth for the root, and ane since it's an alkane, so therefore be methane. Let's look at the other carbon roots that would fit the alkane suffix. So 1 carbon, methane. 2 carbons, ethane. 3 carbons, propane. 4 carbons, butane. 5 carbons, pentane. 6 carbons, hexane. 7 carbons, heptane. 8 carbons, octane. 9 carbons, nonane. And 10 carbons, decane. Notice that after butane, when we start with pentane 5, it follows a system. It's the first 4 that you have to keep track of. Let's look at a straightforward problem. Provide the IUPAC name for the following. Starting with A, we can dissect this one by just counting out the number of carbons. 1, 2, 3, 4, 5. If we counted the other direction, we'd still get 5 carbons. It's always important to count the carbons in any possible direction you can to make sure that you found the longest chain. Therefore, the root for this would be pent. It is an alkane, so this would be pentane. Have we named all 5 carbons that are there? Yes. Are there any substituents? No. So we have found the name for this. It's pentane. Let's look at the next one. In this case, let's make sure that we count every carbon. So 1, 2, 3, 4. Well, is there a longer chain? Well, let's try. 1, 2, 3, 4, 5, 6. And just to make sure, 1, 2, 3, 4, 5. We can see that 6 is our longest chain. So therefore, since 6 is our longest chain, we're going to have hex. And again, this is an alkane, all single bond carbons. So that's going to be hexane. So our parent is hexane. Now that we've named our parent hexane, let's circle it and see if there's anything that's not been named. Well, what you'll notice is we have 1 carbon off to the side. Well, 1 carbon would be meth, but we're not going to use methane. Methane would be a 1 carbon alkane. We're going to use the suffix YL to make it methyl. This is the substituent name for a 1 carbon. If we had 2 carbons, it would be ethyl, 3 carbons propyl, and so forth. So now we have our parent chain, hexane, and our substituent. Next step is figuring out the numbering for the substituent. If we start going from left to right, we'll have 1, 2, and 3. If we go from right to left, we'll have 1, 2, 3, and 4. So our two choices are 3-methyl and 4-methyl. You always go with the lowest number, and so therefore we're going to go with the 3-methyl. If we put that all together, we'll see that we're going to end up with 3-methyl hexane as the name for this compound. Let's look at the next one. Here again, let's figure out the longest chain. So 1, 2, 3, 4, 5, 6, 7. We can go 1, 2, 3, 4, 5, 6, 7, 8. And let's try this one. 1, 2, 3, 4, 5, 6, 7, 8. So we see here that we have 8 as our longest. This points to a common mistake students make. They usually just go left to right without thinking about the direction. Make sure you count all the possible directions you think about, because it may be the branch that goes down, up, that is the longest. In this case, we see that going down is the longest, so we get 8. So with 8, that's going to be octane. Now that we have the parent, let's look and see what is not involved in the octane. So if we see here, we have one carbon group, so that's going to be methyl. Again, remember we use the YL as a suffix. And we have a 2 carbon group. That's going to be ethyl. So we have an ethyl and a methyl. Now, where are these two on the chain? Again, we can go in 2 different directions, left to right and right to left. If we start counting, we'll have 1, 2, 3, 4, 5, 6 for our 2 groups. So we have a 3 and a 6. If we go in the other direction, we'll have 1, 2, 3, 4, 5, 6. Now this one's interesting. Let's evaluate this carefully. We have a 3-methyl and a 6-ethyl. The other direction, we have a 3-ethyl and a 6-methyl. Our numbers are the same. So what's going to rule this if the numbers are the same? Well, what's our last rule in the IUPAC? Alphabetic. Since both numbers directions are the same, 3 and 6, or 3 and 6, we look at our last rule, the alphabetic. Which one would get the nod? The 3-methyl or the 3-ethyl? Ethyl starts with an E, which comes before M, so therefore that's our correct name. If we put this all together, we're going to see that we have 3-ethyl, 6-methyl, octane. There's one other thing that we need to consider. What if we have more than one of the same substituent? Let's look at one more example and see how this is named. Here we have 5 carbons, so that's going to be pentane, and we have 2 methyl groups. We will not call this 3-methyl, 3-methyl pentane. What we'll say is that we have 2 methyls. The way we indicate that we have 2 methyls is that we use the Greek prefixes. Di for 2, tri for 3, tetra for 4, and so on. So therefore, the name for this one would be dimethyl pentane. But we need to say where those dimethyls are, so therefore we need to count where they are. They both would be on 3. Would this be correct name? 3-methyl dimethyl pentane. Remember, every substituent has to have its own number, so the correct name for this would be 3,3-dimethyl pentane. One last thing. When you're doing the alphabetic for the substituents, the prefixes di, tri, and tetra modify or tell you the number of the substituents. So if we have something like dimethyl, it's not the D that gives us the alphabetic, but the M. There's lots of possibilities with organic nomenclature. There's millions and millions of organic molecules. But it is a straightforward system. You just have to practice at using it. Practice organic nomenclature and become confident.